You should be finished with your assessment right now, and what we're going to be doing is just jumping into 1.3 warm-up. So if you could take out your module notes, and what we're going to be doing is just going over the warm-up, just going over a handful of problems, and we'll go through the actual lesson next time I see you. Okay, so what we should have, everyone should have their module packet out, and what we're going to do is look at absolute value. So I want you to realize, guys, some of us might remember absolute value from last year in Math BH, but we're going to take it a step further. So this is the stuff of what we should have seen from last year, these types of problems. When you're given an absolute problem and an absolute value and everything within the problem on one side of the equal sign is in that absolute value. So basically it's saying, what is the distance from a certain number that would equal 4. So remember, distance is always positive, so the distance from 4 to 0 is positive 4. And then the distance from negative 4 to 0 is also positive 4. So right here you would just say x would equal plus and minus 4. Okay? And from here, same idea now. What you want to do is when you're solving this, once you get the absolute value all by itself, it's going to be the absolute value of x equals 1. What you're going to do is set up two equations. The first one is x minus 1 equals 3. And the second one is x minus 1 equals negative 3. So when you solve for these, all we're going to have to do is add 1 to get x is equal to 4. Second one, we're going to do the same idea, just add 1 on both sides to get x is equal to negative 2. So your answer here is x is equal to 4 comma negative 2. Okay. They also have a different notation where it looks like a little fancy bracket and x such that x is equal to 4 comma negative 2. That's the other way you might see it. And finally, when we go ahead and look at this one, I need to get x all by, or the absolute value all by itself. So we're going to divide both sides by 2, which is going to give us x plus 1 is equal to 3. Now I can set up my two equations. The first one is just x plus 1 is equal to 3. And the second equation is going to be x plus 1 equals to negative 3. So when I minus 1, I'm going to get x equals 2. So far I got x equals 2. Same idea here. I'm going to minus 1 to get x equals, and that's a negative 3 right there. And negative 3 minus 1 is negative 4. So my second one is and negative 4. Okay? So that part should have been a review, but now what we're going to do is focus on these absolute value marks. So here, how we solve these now is your same idea, but it's going to be a little different. So the first one is once you get the absolute value all by itself, you just get x is less than or equal to 4. The second equation now, you're going to have x. You're going to flip the sign of the inequality, so it's going to be x is greater than or equal to negative 4. And then there you go. That's your answer. X is less than negative 4 and x is greater than or equal to negative 4. So if you were to graph this, it would look something like this. It's an and problem because it would be negative 4, positive 4. And so you would have a closed circle shaded it to the right to positive 4. So all this would be your solution. So to write this, we would write x is greater than or equal to 4, and it is less than or equal to, is greater than 4, sorry. It is greater than negative 4 and less than or equal to positive 4. Okay? Similar to this one, now we can go ahead and solve it in blue. This one would be the absolute value of x minus 1 is less than 3. All right, we got the absolute value all by itself. So it'd be x minus 1 is less than or equal to 3. And then the other one is x minus 1 is greater than or equal to negative 3. So when I go ahead and solve this, then I'm just going to add 1 to get x is less than or equal to 4. And then I'm going to go add 1 to get x is greater than negative 2. So then I would have a final answer, greater than or equal to negative 2. X is greater than or equal to negative 2, and x is less than or equal to positive 4. All right, last one that we've, as a review, same idea. You're going to divide both sides by 2 to get the absolute value of x plus 1 is less than or equal to 3. So then you're able to create your two inequalities of x plus 1 is less than or equal to 3. And then you're going to get x plus 1 is greater than or equal to negative 3. So then when I go ahead and solve this, I'm just going to minus 1 to get x is less than or equal to 2. Minus 1 to get x is greater than or equal to negative 4. So then I'll have x is greater than or equal to negative 4 and less than or equal to 2. Okay. All right, so now what we're going to do is look at a handful of others. Is that exactly the same? So this one's very similar now, except now those were all AND questions. I want you to realize that when you shaded all these, that the value fell in between these. So like negative 2 and positive 4, it fell right in between these. Okay? The other option, this is called AND problems because it has to satisfy both of these. The other one's called an OR problem. So same idea. Right here, I'm going to have x is greater than or equal to 4, or x is less than or equal to negative 4. So when you graph this, if you have 0 right here in the middle, you have negative 4 here, positive 4 here, they're going to go in opposite directions. So any number less than or equal to negative 4 would satisfy this criteria, or greater than or equal to positive 4. All right. So then over here now, same idea. I got x minus 1 is greater than or equal to 3, or x minus 1 is less than or equal to negative 3. So when I solve this plus 1, I got x is greater than or equal to 4, or x, I'm going to add 1, to get x is less than or equal to negative 2. So then when I graph this, it would look like negative 2 would be going this way, positive 4 would be going this way. Okay. Final one over here, similar idea. Divide by 2, divide by 2. So I would have x plus 1 is greater than or equal to 3, or x plus 1 is less than or equal to negative 3. So when I go ahead and solve this then, minus 1 to get x is greater than or equal to 2, or minus 1, x is less than or equal to negative 4. Okay? All right, so will all absolute value equations have two solutions? Why or why not? There's a few things. No, because it could be no solution. So for instance, if you have the absolute value of some number is equal to negative 5, it's talking about an equation, not an inequality, so there's an equal sign. You can't take an absolute value and have it be negative 5. The other idea here, if you have like something like the absolute value of x plus 5 equals 5, when you do this, you'd have the absolute value of x equals 0, and that would just be 0, okay? All right. What do you notice about the pattern of absolute value with what would be different if we used in part 2? I feel like I'm missing a word here. So it says, what do you notice about the pattern of absolute value with part 1? What would you be different in part 2? So if we go ahead, and when we looked at this, so I would guess it's saying in part 1. So those are in part 1, it's equation sign. Part 1 were equation signs. And then in part 2, it was inequalities. And then what we talked about, these were AND problems. It was between two sets of numbers and all the values in between. It had to satisfy both of these. So if I said you get a prize if you're a girl and wearing blue, you'd have to satisfy both parameters. You'd have to be a girl as well as being wearing the color blue. If you're a boy and wearing blue or a girl wearing red, that wouldn't satisfy. You have to wear both. What do you notice about the pattern and the absolute value? What would be different if we used in part 3? So let's go ahead. Like I said, I think I'm missing a word right here, but the key part is part 3. What it was is those were in inequalities. Those would be an OR problem. So OR problem is when it satisfies one of the requirements. So it would go like this. So if I said, hey, if you want to help on your test, come see me before 8 o'clock or after 2 o'clock. So either one of these are good solutions. So let's go ahead and solve each and sketch a number line to show. So right here, guys, before we do the flip thing, what we need to do is get the absolute value part all by itself. So I need to get this by itself first, and I would do that by adding 5 on both sides. This would give me the absolute value of x minus 2 is less than 3. Okay? From there, I can create my two things. I get x minus 2 is less than 3. And then my other one is x minus 2 is greater than negative 3. So when I solve these, I add 2 to get x is greater than negative 1. Add 2 to get x is less than 5. So for something to be greater than negative 1 and less than 5, let's see, we've got 0, negative 1, 5. First off, it would be open circles, and I would shade everything in between. To write this in the proper form, it would be x is less than 5 and x is greater than negative 1. Okay? You can also write it x such that x such that. And then you could also just have that written right there with the fancy brackets around it as well. Okay? All right, so let's go and look at this one. Minus 1, minus 1, the absolute value of 1 plus b is less than 3. So I write my two inequalities. I would have 1 plus b is less than 3. 1 plus b is greater than negative 3. Minus 1, minus 1, minus 1, minus 1. To have b is less than 2. And b is greater than negative 4. So once again, b is less than 2, and then b is greater than negative 4. All right, so from here then, let's go ahead and create. There's nothing more to do here, so all I do is 10p minus 4 is less than 34. And then my second inequality, 10p minus 4 is greater than 34. So when I went ahead and solved these now, I'm going to add 4, 10p is less than 38 to get p is less than 3.8. And over here, I flipped the sign, did not make that negative. When I add 4 and add 4, I'm going to have 10p is greater than negative 30 to get p is greater than negative 3. Okay, so then this would look like p is greater than negative 3 and p is less than 3.8. Okay, number line, it would be a negative 3, 3.8, open circle, shade in between. All right, so hopefully we're getting the hang of this one now. So we only got a few more. Let's go ahead and look at this now. All right, so here I have negative 8a minus 3 is greater than or equal to 11, and then negative 8a minus 3 is less than or equal to negative 11. So let's go ahead and add 3 to get negative 8. A is greater than or equal to 14. Divide both sides by negative 8. Now this might be something that we forgot in the previous lessons, but anytime I divide both sides by a negative, inequality flips. So this would give me then A, instead of greater than, return to less than or equal to negative 7 over 4. Okay, same idea, add 3 to have negative 8. A is less than or equal to negative 8. Divide both sides by negative 8. To have A, let's flip the inequality, is greater than or equal to positive 1. So A is greater than negative 1 and less than a negative number. So that means this would be an OR problem where I have 1 right here. I'm going to shade greater than and fill this in. And then I'm going to have negative 7 over 4. Filled it in, and it's less than, so it'll be over here. 0 would be about like right there. Okay. We got a little bit more to do here, so let's go ahead and look at this. We're going to add 10 to get 9 times the absolute value of r minus 2 is less than negative 63. Okay, so then when I go ahead and solve this, it's very important to pay attention. If I divide both sides by 9, this would give me the absolute value of r minus 2 is less than negative 7. Now I want to think about this. Whenever you do an absolute value problem like this and you get the absolute value all by itself, it's asking, can this value ever be true? Can an absolute value of this number ever be less than negative 7? The answer here is false. It can't be less than negative 7. No matter what number I plug in for r, it won't work. So be careful with that. So your answer here is no solution. Just be careful with that, because if you do what we taught, and I'm going to do it in red so we know it's incorrect, but r minus 2 is less than negative 7. Add 2, add 2. What we would get is r is less than negative 5. Okay? So you might say, oh, okay, that's good. Well, any number less than negative 5, but if we plug this in, so it says a number less than negative 5. So if I plugged in negative 6, negative 6 minus 2 is the absolute value of negative 8. The absolute value of negative 8 is equal to positive 8. Positive 8 is not less than negative 7. So just be careful with those. They're going to try to trick you. All right, so now let's go ahead and look at a little different one. Add 1 to get 2 times the absolute value of 10. B plus 7 is equal to, or excuse me, is greater than 74. When I divide both sides by 2, this will give me, let's see, 35, 36, 37. The absolute value of 10b plus 7 is greater than 37. So I got the absolute value all by itself, so you're just going to break out that into two equations to get 10b plus 7 is greater than 37. And then you're going to have 10b plus 7 is less than negative 37. So minus 7, this will give me 10b is less than negative 44, which gives me b is less than negative 4.4. Then over here, minus 7 to get 10b is greater than 30. Divide by 10 to get b is greater than 3. So now that I have my two things, I'm just going to have my number line. I'm going to have 3 right here, shade everything bigger, and then negative 4.4 here, open circle, shade everything to the left. Okay? All right, just a few more. All right, here, let's go ahead and zoom through this. Minus 8. This would give me 4 times the absolute value of 6 minus 2a. And that is less than or equal to 16. When I divide both sides by 4, this gives me the absolute value of 6 minus 2a is less than or equal to 4. So then now I have my two things I'm going to make my inequalities of 6 minus 2a is less than or equal to 4. 6 minus 2a is greater than or equal to negative 4. So when I solve this, minus 6 to have negative 2a is less than or equal to negative 2. When I divide both sides by negative 2, I'm going to have a is greater than or equal to, what did I divide by negative? By positive 1. And then over here in pink, minus 6, no, it's not pink. Minus 6 to have negative 2a is greater than or equal to negative 10. Divide by negative 2 to have a is, flip the sign, a is less than or equal to positive 5. So then right here I'm going to have a is greater than or equal to positive 1. And then I'm going to have and a is less than or equal to 5. Another way, a is greater than or equal to 1, less than or equal to 5. Number line, here is 1, here is 5. Close circle, shade in between. All right, guys, so we have 2 more, but I'd like you guys to finish those on your own. So this is the end of the video. If you have any questions, feel free to email me or jump on, okay? See you guys later.